All right, so we are going to work out the mechanism of a reaction using the overall balanced equation and the rate equation. So this is the balanced equation here. That's the rate equation. Because in the rate equation we have NO2 and O3, that means in step 1, which is going to be our slowest step, our rate determining step, that's the assumption we are making, you will have 1 mole of NO2, 1 mole of O3. If the rate equation was different, if it was NO2 squared, then in the rate determining step, you will have 2 NO2. Right, so we carry on. By the way, the method is here if you want to read it and stop the video, that's fine. So when we add up step 1 and step 2, so all the reactants of step 1, all the products of step 2, then you will get the balanced equation. But we can see that we have 2 moles of NO2 in the balanced equation. At the moment, we only have 1 mole of NO2. So then the second mole of NO2 must come from step 2. All right, so at this point, you are going to work out the product of step 1. And here you have different choices. So you could add up the products together, the reactants together, that gives you NO5. As long as the equation is balanced, it's correct. Doesn't matter if you haven't seen this molecule before. You could also maybe write NO3 and NO2. Any combination will do. You can be creative. As long as it's balanced, it's fine. Now, you see NO5 is not a product of the balanced equation. So that means we need to get rid of it. And to do so, we write it as a reactant of step 2. So then we have to get the products of the balanced equation now. So we try to do so. We write here N2O5 and O2. And then you check if the step is balanced. Yes, it is balanced. Then you add up these reactants. And that should give you this. You add up these products. And this should give you that. What you will see is that the NO5 cancels out when you do that. And that's how you get the balanced equation. If you were following the pathway on the right, then you see that O2 from step 1, it's a product of the balanced equation. So you don't want to get rid of it, you keep it there. What you want to get rid of is NO3 because it's not a product of the balanced equation. And when you do that, you want to get this product, which we haven't got yet. That works out nicely because the step is going to be balanced. And again, if you add up step 1 and 2, it gives you the balanced equation. That is your checkpoint, and the question is finished. If you have questions, you can put them in the comments. Bye for now.